Hey, how's everybody doing? This is Suzanne again for Suzanne's Tutoring. You are probably watching this on YouTube, where you can find my channel at YouTube/Suzanne's Tutoring. Don't forget to like and subscribe, and when you're looking for me, just look for the big red S. You can also find my website at Suzanne'sTutoring.com. So yes, I am now available on YouTube and on my website. You're getting some free study tips, the free PDF downloads, free tutorial playlists, and there are never any ads, there are never any fees, there are no memberships to sign up for, there are no forms to fill out. No kidding. I don't ask for your personal information at all because it's none of my business.
Hello again. So this is another part of the video, technically part of Factoring Part 2, the sequel. These are the practice problems because I know that the Part 2 video does a really good job at explaining FOIL and factoring the quadratic formula, but it doesn't give you much in the way of practice. So we're going to go through some practice problems, and we're going to also review some general rules that you can look out for in multiplication, division, and addition, subtraction that might be a little bit of a help. So just as a friendly reminder, or maybe you've never thought of these kinds of mathematical patterns, but it gets a little bit easier once you realize just how many predictable things there are when you're working with numbers. Patterns in multiplication. If you have an even number and you multiply it by an even number, your answer is going to be an even number. There's no way around that. So even number times an even number. So 2 is even times 4, that's going to be 8. And see, 8 is even. If you have 16 times 6, that's going to be 96, which is an even number. If you have an even times an odd number, it's also going to be even. So anytime you have an even number that gets in there, it turns the whole thing into even, no matter what, even if it's times odd. So let's look at this and see that it's true. So an even number times an odd. So if you have 2, which is even, times 3, which is odd, that's going to give you 6, which is even. 4 times 7, that's an even times an odd, that's going to be 28, which is even. So as you can see, anytime you have an even number in there, the answer is always going to be even when it comes to multiplication. The only time a product is going to be odd, and a product is the official technical term for the answer when you multiply something together. You know, like A times B is going to equal a product. So that's just specifically for multiplication. So anytime you have a product, it's going to be even. The only time it's going to be odd is when both of the multiples are also odd. See, odd times odd equals odd. That's the only time the product is going to equal odd. So like odd times odd, 3 times 3, that's going to give you 9, which is odd. If you have 5 times 5, that's an odd times an odd, that's going to give you 25. If you have 3 times 5, that's an odd times an odd, that's going to give you 15. So the only time you're going to get an odd number as a product is when both of the multiples are going to be odd. Any other time, the answer is going to be even. So an even times an even is going to be even, and an even times an odd is going to be an even number. So what does that mean when you're factoring something out? Well, you can do it in reverse. So this would be the division aspect of it, because again, multiplication and division are actually kind of the same thing. They're just backwards and forwards. So if you have an even number, if you're factoring out an even number, you could have as the multiples either an even times an even, or your multiples could be an even times an odd. So one multiple could be even and one multiple could be odd, or both multiples could be even if you're factoring out an even number. If you are factoring out an odd number, the only answers that you can have that you're going to get is an odd times an odd. Because any other time, if you have an even times an odd, then that's going to go back to being an even product. So let's look at some patterns in subtraction. If you have an even number minus an even number, you're going to get as an answer an even number. So if you have, let's say 12 minus 6, that's going to give you 6, which is an even number. Or 18 minus 4 is going to be 14, which is an even number. Now, if you have an even number, if you start with an even number and you subtract an odd number, then that's going to give you an odd result. So if you start with 12 and you subtract 5, well, then that's going to give you 7, which is odd. Or if you have 18 and you subtract 7, that's going to give you 11, which is odd. And by the way, don't forget, you don't need to memorize these. These just naturally occur when you're doing math. But if you're aware of it, it might provide a little shortcut to you. It might make things a little bit easier if you bring this to mind when you're factoring things out. So you don't have to memorize these, but it's just good to go over. Now, if we start with an odd minus an even, we will also get an odd. So do you see how the only time our answer in subtraction is going to be an even number as the answer is when you're subtracting an even minus an even? Because if you subtract an even minus an odd, you get odd. If you subtract an odd minus an even, you get odd. So what if you subtract an odd minus an odd? Well, if you subtract an odd minus an odd, you're also going to get even. So you see, the only time you're going to have odd numbers as the result of subtraction is when it's you're using mixed odds and even numbers in the equation. So an even minus an odd, you're going to get an odd. An odd minus an even, you're going to get an odd. But an odd minus an odd, you're getting an even. And an even minus an even, you're getting an even. So that means the only time the difference, which the difference is the technical term for a subtraction equation. So difference is the result as the answer from a subtraction. The only time the difference will be even is when both numbers are either even or odd. So when they're the same, you're going to get an even number. When they're different, you're going to get an odd number. Now, if that doesn't make sense to you, then pause the video and just try to, just make up some problems and do them and see how true that is. 24 minus 14 is 10. See, that's an even minus an even. That's going to give you an even. An odd minus an odd. 27 minus 7 is 20. That's an even. 27 minus 6, that's going to give you 21. That's going to give you an odd. 28 minus 5, that's going to give you 23. That's going to give you an odd. So when we're doing this with addition, because again, subtraction and addition are pretty much the same thing. They're just backwards and forwards of the same thing of each other. An even plus an even is going to give you an even. See, those are the same. Or an odd plus an odd is going to give you an even because they're the same. So if we have the same, then it's going to give you an even. Same, even. Or if you have an odd number as a result of an addition problem, that means you have to have had an even plus an odd number. They have to have been different in order to get an odd. So let's look at this. So if we have, let's see, even. So if we have the number 12 and we're adding stuff together to get it, we could add 1 plus 11, or we could add 2 plus 10 as an example. Well, look at these. This is odd, this is odd. So these are the same. This is even, this is even. So these are the same. So if they're both the same, you're going to end up getting an even number. If you add the same, if you add an odds or if you add evens together, the result is always going to be evens. But if we go even and odd, if we mix them up, you're going to get an odd number. So if you start with an odd number and you're trying to figure out what numbers added together give you this odd number, it has to be mixed. It has to be one even and one odd added together in order to get the odd. So 13, you could have 10 plus 3, or you could have 11 plus 2. Well, either time, these are going to be different. This is even, the 10 is even, and the 3 is odd, so it's different. The 11 is odd, and the 2 is even, so it's different. So if you have different numbers added together, that's the only time your result is going to be an odd number for addition. So if the numbers are both the same, even or odd, then the answer is always even. So same equals even. Different equals odd. Also, just as a review, let's review negatives and positives when we are multiplying, dividing, and adding and subtracting. Now remember, adding and subtracting are brother and sister, and they live in a house with the same set of parents. And multiplication and division are brother and sister, and they live in a different house with their parents. And these are all cousins, but they don't live in the same house. They live in different houses. They have different parents. So these are siblings, brother and sister. So since these are siblings, brothers and sisters have the same parents, so they go by the same set of rules. They're under the same roof, so they have the same set of rules. And multiplication and division are brother and sister, and they live under one roof, so they have the same set of rules. So just keep that in mind when we're doing stuff. So if you wonder why something turns out in a certain way, that's why. So let's talk about for a minute adding and subtracting. When we're adding and subtracting negative and positive. And if this is still confusing to you after we do this, then I would suggest doing a lot of practice problems, just adding and subtracting negative and positive numbers together, and get out a number line or just make one like I'm doing right now. So see, here's 0. So everything on the left side of the 0 is a negative, and everything on the right side of the 0 is positive. So we have positive 1, 2, 3, 4, 5, 6, 7, and negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So I always like to think of this 0 right here as kind of like a mirror, because it's a mirror. They're mirror images of each other. It's not negative 1, negative 2, negative 3, negative 4, and then 0, and then 1, 2, 3, 4, right? They're not going in the same direction. They're going in opposite directions. The numbers get bigger as you go to the left when it's negative. The numbers get bigger when you go to the right when it's positive on a number line. So that helps me out a lot to visualize that. So whenever you have if you're, let's say adding first. If you're adding, let's say a negative plus a positive, okay, whatever the first number is, let's say negative 5, that's where we're going to start. We're going to start at negative 5. And then what we do is, this number is how many steps we're going to take. So if it's a positive 3 or plus 3, then a plus, remember, a plus goes in this direction, goes to the right. A negative goes to the left. So if it's a plus 3, we're going to start at that negative 5, and we're going to go take 3 steps. 1, 2, 3. 3 steps to the right because it's positive, and that gives us a negative 2. So our answer is negative 2. Now if we start with a positive number, say 2 plus a negative 5, we can start at the 2, positive 2, and then we need to take 5 steps, but since this is a negative 5, we're going to take the steps in the negative direction, toward the left. So we're going to start at the 2 and go 1, 2, 3, 4, 5. So that's going to give us a negative 3 as an answer. Now check this out. I wrote 2 plus negative 5. It's the exact same thing if I were to have just written 2 minus 5. Same exact thing. It's just shorter to write 2 minus 5. But you can write 2 plus negative 5 if that helps. So a lot of times when you're doing math and you have something like 2 minus 5, or sometimes especially if the first number is negative also, like when you're subtracting negative numbers, negative 2 minus 5. Well, you can just turn this into a plus a negative 5, and it's the exact same thing. So negative 2 plus negative 5 is the exact same thing as negative 2 minus 5. Same exact thing. Now, if we're multiplying or dividing negative and positive, then that's a different set of rules. Because remember, multiplication and division are brother and sister, and they live in a different house, so they have different rules. If you were going to multiply just a regular old positive number times a regular old positive number, well, what does that give you? Well, of course, that's going to give you a positive number, right? So 2 times 3 is 6. You don't even worry about any negative because negative didn't enter into it, right? So a positive times positive is going to give you positive. Now, what if you multiply a negative times negative? Well, a negative times negative is also going to give you a positive. So if you have negative 2 times negative 3, that's going to give you 6. So if you have the same things, these are the same, if it's a positive times positive, or if it's a negative times negative, the answer is always going to be positive. The only time you're going to get a negative answer when you're multiplying anything, the only time your answer is going to be negative when you multiply is when they're mixed numbers that you're multiplying. If you're multiplying a positive times negative, that's when you get a negative. Or a negative times positive, doesn't matter. It doesn't matter the order. That's when you get a negative. So if you take a 2 times a negative 3, that gives you a negative 6. If you take a negative 2 times a positive 3, that gives you a negative 6. So, okay. So now that we've gone over that, we can start doing some practice problems. And here's a list of practice problems, and I'm posting this PDF on my website so you can download these. So if you want to, pause and get out your notebook and calculator. Take a minute, pause the video, and see if you can work through these by yourself. Don't worry, I'll wait. I'll be right here. So welcome back. Thanks for unpausing me. And let's go through these. This is the first page. And you see these are all iterations of the same problem. But this one, it's all x5 and x2 in the parentheses. But this is x plus 5 times x plus 2, x minus 5 times x plus 2, and x plus 5 times x minus 2. So that's how I have these pages set up. And remember, we are going to do FOIL because these are two parentheses times each other. First, outer, inner, last. So the firsts are going to be these x's. So x times x, it's not 2x now, don't get tripped up. X times x is x squared. Now we have outers. So the outers is going to be this outer x here and this outer 2 right there. So x times 2, that's going to be 2x. And we're going to put a plus sign here because the 2x is positive. So we're just writing positive 2x, which translates into add 2x. Now the next step is inner. So the inners, the inside numbers in these two parentheses, 5 times x, well, that's going to be 5x. And we write a plus sign here. We know to add because it is positive 5x. And finally, last but not least, last. So 5 times 2 is 10. And since the 10 is positive, we know to put the plus sign there. But we're not done because we need to combine like terms. And these are the like terms. Now, we can't add x squared to anything else other than another x squared. But we do have a 2x and a 5x. So those are like terms. So 2x plus 5x is 7x. And then you just bring down the x squared. Oh, and of course we put the addition because it's positive 7x. And then we just bring down the positive 10. So the answer is x squared plus 7x plus 10. Did you get that? I'm sure you did. All right, let's do this next one. Well, the firsts are the x times x. So, of course, that's x squared. And the outers are the x times 2. So that's going to be a positive, and see this is a positive 2. So that's going to be a positive 2x. X times positive 2 is positive 2x. And then the inners are, look at this, a negative 5 times x are the inner numbers. So a negative 5 times x is going to be a negative 5x. And then the lasts are a negative 5 times a positive 2. So that's going to be a negative 10. Now we need to combine these like terms because these are both just regular old x's, a number with an x multiplied to it. So a 2x minus 5x is negative 3x. And then you just bring down the x squared, and you bring down the negative 10, because see, this is a negative 10. So the answer is going to be x squared minus 3x minus 10. So do you see how these two answers compared to each other are different because of this one little negative that we threw in right there for the negative 5? So let's go on to this third problem. First are x times x, so that's x squared. Outers are x times 2, or negative 2. Now we have a negative 2, so that's a negative 2x. Inners is positive 5 times x, so that's a positive 5x. And then lasts are positive 5 times negative 2, so that's a negative 10. So now we combine these like terms. So negative 2x plus 5x is a positive 3x. And then we just bring these numbers down, x squared and negative 10. So the answer is x squared plus 3x minus 10. Now do you see how these two sets of answers differ from each other? Because we changed the position of the negative sign between these two. In this one, in the middle one, it was a negative 5. The minus sign, the subtraction sign, was in the first set of parentheses. But in this one, the minus sign of the subtraction was in the second set of parentheses. So see how this changed? There's a positive 3x there and a negative 3x there, but they both have negative 10 as the last number, as their C number. And when I say C number, remember the quadratic equation is that. So the C number, when I say C number, I'm talking about negative 10, whatever the lonely little number without the X is at the end of the equation is, that's your C number. So, okay, we're going to go faster this time because you've already paused me and tried to figure these out for yourself, right? Right. Okay, so first, x times x is x squared. Outer, x times 6 is positive 6x. Inner is positive 11 times positive x is positive 11x. And last, positive 11 times positive 6 is positive 66. And then you combine these like terms. 6x plus 11x is 17x. And you just bring the rest down. There you go. Now what about this one with the negative number in the first set of parentheses? Well, the first we know is x squared. And then outer is x times positive 6. So that's positive 6x. And then inner is negative 11 times x, which gives you negative 11x. And then last is negative 11 times positive 6. So that's going to give you a negative 66, because negative times positive is a negative, because there's two different types of numbers. And then you combine these like terms, positive 6x minus 11x, which is the same thing as saying positive 6x plus a minus 11x. But I don't really do it that way, but a lot of people do. Whichever one makes more sense to you. So positive 6x minus 11x is going to give you a negative 5x. So you just bring these down. So the answer is x squared minus 5x minus 66. Now let's do this last one with the negative number in the second set of parentheses instead of the first set. So we have x squared, we know that. And then outer is x times negative 6, so that's negative 6x. Inner is 11 times x, so that's positive 11x. And last is 11 times negative 6, so that's negative 66. You combine these like terms. A negative 6x plus 11x is a positive 5x, and then you just bring the rest down. So see, when you switch up the positives and negatives from one set of parentheses to the other, the only thing that changes is this little middle number right here. It could be positive or it could be negative, just depending on where the placement of the negative number or the subtraction sign in the parentheses is to start with. But everything else is the same. These are both negative 66, and these are both x squared. All right, so first is x squared. Outer, because remember, FOIL, first, outer, inner, last. Outer is x times 13 times positive 13, so it's 13x. Inner is 24 times x, so it's 24x. And then last is 24 times 13. So you're going to have to get your calculator out probably for this one. So 24 times 13 is 312. And then you combine these like terms. 13x plus 24x is 37x, because these are both positives. And then you just bring down the rest. Positive 312, x squared. Now let's do this middle one. The first are x times x, which is x squared. And then outer is x times negative 13, which is negative 13x. Inner is 24 times x, so that's 24x. And then the last is positive 24 times negative 13. Well, we already know 24 times 13 is 312, right? Because we did that previously on this one. But since it's a positive 24 times a negative 13, that means it's going to be a negative number because they're different. So it's going to be negative 312. Now you just do the like terms, combine like terms. We have a negative 13x plus a 24x, or plus a positive 24x, same thing. So that is going to give us a positive 11x. So you just bring the rest of these down. So that's our answer. Now the next one is x times x is x squared. Outers is x times positive 13, so it's positive 13x. Inners is negative 24 times x. And last is negative 24 times 13, so that's also negative 312. And then you combine these like terms. So this time we have a positive 13x and a negative 24x. So if we have a positive 13x and a negative 24x, that's going to give us the opposite sign of what we had over here. We had positive 11x, so this is going to give us a negative 11x because we swapped these two numbers right here. And then we just bring the rest down. So x times 7, and you know what? I'm going to shake this up a little bit, and I'm going to change this. I'm going to change these to both negatives, and let's see what happens. So first is x times x, so that's x squared. Outer is x times negative 14, so that's negative 14x. Inner is negative 7 times x, so that's negative 7x. And last is negative 7 times negative 14. So negative 7 times negative 14 is going to be a positive 98. Combine these like terms. Negative 14x plus a negative 7x is a negative 21x. And you bring down the 98 and you bring down the x squared. And there's your answer. Now what if we would have done the x plus 7 times x plus 14? Well, x times x is x squared. X times 14 is 14x. 7 times x is 7x. And 7 times 14 is 98. So if you combine these like terms, we're going to get 21x. Bring these down. So when it's a negative times a negative, the only difference in the answers, if we have the exact same thing but it's positive times a positive, is that this is going to be a negative and this is going to be positive. Just like when we change the negative, the placement of the negative, switch them out in different parentheses. The only difference is going to be that middle term. So this would be x squared plus 7x minus 14x minus 98. Combine these like terms. 7x minus 14x is a negative 7x. So bring these down. And there's your answer. So this answer should be the same thing except positive 7x. So let's see if that works. X squared minus 7x plus 14x minus 98. Combine these like terms, and this is going to be a positive 7x. Just bring these down. And there's your answer. And see, I was right. This is a negative, this is a positive, everything else is the same. Okay, now that we've done those problems, let's move on, and we're going to do the exact same thing, but I made it a little bit more difficult, just increase the difficulty level, and let's breeze through these really quickly before we get to the factoring the quadratic equations, which is the reverse of this, the reverse of FOIL. So on this one to the left, we have 3x plus 23 times 12x plus 2. So we want to do first. So first is going to be the 3x times the 12x. So we know the x times the x is x squared. But we also have to do this 3 times 12 part of it as well, since we have numbers here. So 3 times 12 is 36. So the first is going to be 36x squared. And then we go to the outer, 3x times 2. First outer and last. 3x times 2 is 6x, and that's positive. And then inner, 23 times 12x is going to be 276x. And then last, 23 times 2 is going to be 46. That's positive. So then we combine these like terms. So 6x plus 276x is going to be 282x, and that's a positive. Then we bring down the 36x squared, and we bring down the positive 46. So I hope you can see that you're doing the exact same thing that we were doing earlier. The only difference is that there are numbers in front of these x's now, and so not only do we need to have the x squared there for x times x, but we need to also have the number there for the 3 times 12. So let's do this one over here with the negative. We have 3x times 12x, so we know that's 36x squared. The outers is 3x times 2, so that's a positive 6x. The inners is a negative 23 times 12x, so that's going to be a negative 276x. And then the lasts are a negative 23 times a positive 2, so that's going to be a negative 46. Now we combine these like terms. We have a positive 6x minus a 276x. We have a positive 6x minus 276x, so that's going to give us a negative 270x, and then we just bring down the negative 46 and the positive 36x squared. So let's do this one. We have the first is going to be 11x times 7x, so that's going to be 77x squared. Don't forget that squared. And then outer, 11x times 5 is going to be a positive 55x. And then inner, 13 times 7x is going to be a positive 91x. And last is 13 times 5, and that's going to be a positive 65. And then we just combine these like terms. 55x plus 91x, that's going to be 156x. And then we just bring down positive 65, and we bring down the positive 77x squared. And there you go. And I'm sorry, this is 146x. Oops, 146x. So if you were looking at that going, how did she get a 156? You were right, and I was wrong. All right, let's do this one. 11x times 7x first, we already know is 77x squared. Outers is 11x times 5. We know that's positive 55x. Inners is negative 13 times a positive 7x, so that's going to be a negative 91x. And then last is a negative 13 times 5, so that's going to be a negative 65. So now when we combine these like terms, we have a positive 55x minus 91x. So a positive 55x minus a 91x is going to give us a negative 36x. So we just bring down the negative 65 and we bring down the positive 77x squared. So the answer is 77x squared minus 36x minus 65. So let's do this one. The first is 13x times 11x. So we know that's going to have an x squared at the end of it. And now we just need to do the 13 times the 11, which is 143. Then the outers is 13x times 17, which is a positive 221x. The inners is a 7 times an 11x, which is a 77x. And the last, a 7 times a 17, is going to be a positive 119. Now we combine these middle like terms. 221x plus 77x, we know that is going to end with an x. It's an 8. It's going to be 298x positive. And then we just bring down our 143x squared, and we bring down our positive 119. Now let's do this one over here. 13x times 11x. Well, we know that's 143x squared because we just did it over here. And now outers, 13x times a negative 17. 13x times a negative 17 is going to be a negative 221x. And then the inners, 7 times 11x is going to be a positive 77x. And then the last, 7 times 17, but it's a negative 17, so we're going to get a negative 119. Now we need to combine these like terms. Now we need to combine these like terms. So a negative 221x plus 77x is going to be a negative 144x. And then we just bring down our negative 119 over here, and we bring down our negative 143x squared over here. All right, so here's our next set of problems. Here's a 7x times a 24x is the first. So 7x times 24x is going to be 168x squared. And then the outers, is first, outer, inner, last, FOIL, is going to be 7x times a positive 36, which is a positive 252x. And then the inners, 2 times 24x, is going to be a positive 48x. And then the last, 2 times 36, is going to be a positive 72. And then we combine these like terms. This is going to end in x. That's going to be 300x even, positive. And then we just bring down our other numbers, the positive 72 and the positive 168x squared. So let's try it over here. The first, the 7x times 24x, we know is going to be 168x squared. But then we have a 7x times a negative 36. So a 7x times a negative 36 is going to be a negative 252x. And then we have a negative 2 times 24x. So that's going to give us a negative 48x. And then we have a negative 2 times a negative 36. So that's going to give us a positive 72. And why is that positive? Because these are both the same. A negative times a negative makes a positive because they're the same. It's only when you mix them up and go negative times positive or positive times negative, that's the only time you're going to get a negative as an answer. Okay, so now we need to combine these like terms. Well, negative 252x minus 48x, we can also call this plus a negative 48x. It's the exact same thing. So negative 252x plus negative 48x. But we already have over here positive 252x plus positive 48x gives us 300x. So wouldn't it just make sense that a negative 252x plus negative 48x is also going to give us 300x, but it's just going to be on the negative side of the 0 on that number line? And then we just bring down the positive 72, and we bring down the 168x squared. Okay, so now that we've done the FOIL part of it, now we're going to undo the FOIL, or unfoil it, as I usually say, and we're going to start with the quadratic equation, and we're going to turn it into two sets of parentheses multiplied by each other. So now we're going to do backwards FOIL. We're going to do the quadratic equation, which is all about all the factoring that you've been doing, that I've been talking about in this video, that you've been practicing up until now. So here is a list of some practice problems, this page and the next page. So take a look at these. These are also available on my website to download, along with all the other practice problems. So feel free to pause me, get out your calculator and your notebook again, and try to do these on your own. All right, good job coming back and not giving up on yourself. So here is the first page of practice problems. These are the easier ones where there's no a number, there's no number in front of the x squared. So let's try to do these first, okay? So here is the first set of problems. And if you remember, when we're doing these factoring, what we want to do is we want to take this c number right here, and we want to factor this c number, and we want results that when the multiples are added together, that two numbers times each other gets 10, but when you add them to each other, you're going to get 7. So if we factor out a positive 10, we start with 1. 1 times 10 is 10. Now, if 1 times 10 is 10, so we have that down, does 1 plus 10 equal 7? No, so that's not going to work. So what about 2 times 5? 2 times 5 equals 10. So if 2 times 5 equals 10, does 2 plus 5 equal 7? Yes. So those are the numbers that we're going to use. So if you draw out your parentheses here, and this is just a regular old x squared with no numbers in front of it, so we know that we're going to have an x at the beginning of each of these parentheses. And then we just want to plop those numbers, those multiples of 10 that add up to get 7 right in there at the end positions of the parentheses. And there you go. The answer is parentheses x plus 2 times parentheses x plus 5. Now let's go on to the next one. We have x squared minus 3x minus 10. So we need to factor, again, we need to factor this negative 10. Now this is negative this time. This one was positive, but this one is a negative 10. We need to factor out a negative 10 until we get two multiples that multiply together give us a negative 10, but when added together, they're going to give us this negative 3 right here. So if we need multiples of negative 10, we can go negative 1 times 10, but negative 1 and 10 added together do not give us this negative 3. So that's not going to work. Well, what about the reverse? What about positive 1 times negative 10? So that'll give us negative 10, but again, 1 plus negative 10 is not going to give us this negative 3. So what about negative 2 times 5? Well, negative 2 times 5 will give us negative 10, but will negative 2 plus 5 give us this negative 3? Now be careful now. No, it will not, because negative 2 plus 5 equals positive 3, not negative 3. So what do we need to do to get these numbers arranged so that when added together we get a negative 3? Well, we just switch the negative sign on this. So we're going to do a positive 2 times a negative 5. So positive 2 times a negative 5 still gives us a negative 10. But that, when added together, positive 2 plus a negative 5 will give us that negative 3 we're looking for the middle number. So awesome. Now we have our numbers, positive 2, negative 5. So we draw out our parentheses. We don't have any number in front of the x squared, so we know these are just going to be x's at the beginning. And then we go positive 2, negative 5. And that's your answer. Now what about x squared plus 3x minus 10? Now the only difference is that this is a positive 3x, and this was a negative 3x that we were dealing with. But the end number, the c number, is still a negative 10. There's negative 10 there, there's negative 10 here, so we still have to factor out negative 10. But we need these multiples now. When multiplied together, it gives us negative 10, but when added together, it gives us positive 3. But do you remember we ran across that when we were doing this middle problem right here? If we had the negative sign on the wrong number, if we had the negative sign on the 2, negative 2 plus 5, that gave us a positive 3, right? So we couldn't use it on here because we needed a negative 3. But we can definitely use it here. Negative 2 plus 5 is a positive 3. And negative 2 times 5 gives us a negative 10. So we can make out our parentheses. There's no number in front of the x squared, so we know these are just going to be plain old x's at the beginnings of the parentheses. And then we plop this negative 2 and positive 5 into the last positions of the parentheses, and there you go, that's your answer. So do you see how in this one, the negative sign was in front of the 2 in that first parentheses, but in the middle problem, the negative sign was in front of the 5 in the second set of parentheses, and that made all the difference. Okay, and now we have x squared plus 17x plus 66. So again, don't be scared just because they're larger numbers. It's the exact same thing that what we've been doing. We need to factor out this 66. So when the numbers are multiplied together, they give us 66. But when they're added together, the same numbers will give us this positive 17. So with 66, we know that 1 times 66 is 66, but that's not going to get us to 17, right? So 2 times 33, but 2 plus 33 is not going to get us to 17. 3 times 22. Now, is 3 times 22 going to get us to 17? Oh, close. It gets us to 19 if one of these would have been negative. But nope. You can't get close. You got to get right exactly on. So what about 4? Does 4 go into 66? No. Does 5 go into 66? No. Does 6 go into 66? Yes, 11 times. So 6 times 11 gives us 66. Now, does 6 plus 11 give us that 17 we need? Yes. So we know that our multiples are going to be 6 and 11. So we just draw out our parentheses here with the x's, and we plop a positive 6 and a positive 11, and there's your answer. Now here's the middle problem, x squared minus 5x minus 66. Well, so now we still need multiples of 66, but they need to make it negative 66, and when added together, we need to get a negative 5. So let's try this again. We have a 1 and a 66, and it doesn't matter if the negative is on the 1 or the negative is on the 66. That is not going to get us to a negative 5. What about the 2 and the 33? No, 2 and 33, even if one of these was negative, is not going to get us to negative 5. So we can't use either one of those. What about 3 times 22? No, if those put together, are not going to get us to a negative 5. What about 6 and 11, just like last time? Yes, because 6 times 11 is 66, but we need the 66 to be negative, right? So that means one of these numbers, we have to tack on a negative sign to it. And since we need a negative 5, we're going to put the negative number on the larger multiple, so we make sure that when we add those together, it's going to give us a negative number. So 6 plus a negative 11 equals negative 5. So that's what gives us the negative 5. So we can make our parentheses out, and we can put a positive 6 here and a negative 11 right there. Now what about this last one? It's the same thing, except this middle problem was a negative 5. This last problem is positive 5. And we still have this negative 66 we're working with. So now we just need a positive 5. So if over here in the middle problem, if we put the negative sign on the 11, so when added together, that 6 and 11 would give us a negative 5, doesn't it make sense that if we just change which number the negative sign is on, that's going to give us the positive 5 instead? So negative 6 plus 11 is positive 5, and negative 6 times 11 is negative 66. So we found our numbers already. And there's your answer for that. And see, it's just a difference of where the negative number was placed. We're using the same numbers, we're just changing where we put the negative. Okay, so now we have an x squared plus 37x plus 312. So we need to factor out this 312 so that we get two numbers that, when added together, is going to give us this positive 37. So 312, well, we can do 1 and 312, but if we start all the way at 1, we're going to be doing this forever. So let's speed ahead a little bit, and let's come up with something that is that makes 37. This is a positive 37, so we're probably going to have, and this is positive 312, so we're going to have two positive numbers probably as the multiples. And so there's really no way around this. This 312 is an even number, so we know we can go 2, but that's not going to give us 37. So we're going to jump ahead a little bit, and I'm going to go all the way up to 13. 13 times 24 is 312, and if you add 13 plus 24 together, you're going to get 37. So those are our numbers. And I just skipped ahead a little bit, but what you want to do is you just got to do it out manually until you get comfortable with it, and then we can try to do some shortcuts or something for these larger numbers. But I want you to do these manually so you get used to it. So you could go, 3 and 312 is 104, so that's not going to give us 37. And does 4 go into 312? Does 5 go into 312? All the way up until you get to that 13. And then, of course, you're going to have to use your calculator for this, so you'd have to go 312 divided by 13, and that gives you the 24. So we're going to go x plus 13 times parentheses x plus 24. Now in this middle problem, we have a negative 312, but we need two numbers that are going to give us a positive 11. So if we need a negative 312, you know that one of these multiples is going to have to be negative in order to get that negative sign in the 312. So let's try out the numbers that we were using before, that 13 and 24. If we have a negative 13 times a positive 24, that's going to give us a negative 312. And if we add negative 13 plus 24, that's going to give us a positive 11. So those are still our numbers, but it's where we're putting the negative sign is what's changed. We're putting a negative sign in here. In the first row, or the first column, we didn't have any negative signs. Now here's the last column, which is the same as the middle column, except we have a negative 11 that we need to deal with, and the negative 312 is still the same. So since the positive 11, we found out the perfect multiple numbers are negative 13 and positive 24, wouldn't it make sense that if we need a negative 11 now, we would use the numbers positive 13 and negative 24? Because add those together, and you get negative 11. It's the same answer, except where the negative sign is placed. Now x squared minus 21x plus 98, so that means we have to factor out 98, and we have to come up with something that's going to give us a negative 21. So think about this. If we need two multiples, when multiplied together, give us a positive 98, so this positive 98, but when added together, give us a negative number, then wouldn't it make sense that these multiples multiplied together to get 98 are going to have to both be negative? Because if you take a negative times a negative, you get a positive. But if you add a negative plus a negative, you're going to get a negative. So if you factor out 98, you can go negative 7 and negative 14. When you multiply those together, it gives you a positive 98. But when you add negative 7 plus negative 14, that's going to give you negative 21. So x minus 7 and x minus 14. Now in the middle column, we have x squared minus 7x minus 98. So now we're going to be factoring a negative 98. So that means one of these numbers is going to be negative and one of these numbers is going to be positive. And then when added together, they need to give us a negative 7. So since when added together, a negative and a positive number added together is going to give us a negative 7, then that means the negative sign up here for the multiples 98 is going to go on the larger number. So if we have a positive 7 and a negative 14, then positive 7 times negative 14 is going to give us negative 98, but positive 7 plus negative 14 is going to also give us a negative 7. So our answer would be x plus 7 times x minus 14. And I bet you can guess that since this answer was for a negative 7 here, and the only difference in this problem is that this is a positive 7, what should we do? We should take those exact same numbers and just change where the negative sign is. So we're going to put the negative sign on the 7 this time, and the positive on the 14. So we're going to go x minus 7 times x plus 14. And that will give us the negative 7 instead of positive 7 in the middle. Now, if I'm going too fast for you explaining these, a lot of this has to do with knowing your negative and positive numbers. And I did this on purpose because negative and positive numbers trip up even advanced students. For some reason, I guess we don't get enough practice on it when we're kids, and then we're kind of hazy on it when we get to college, and it really trips us up. So I really made sure that I did a lot of negatives, threw a lot of negatives in here. I did that on purpose because if you can master this, if you can get a handle on this stuff, then you should be okay. But it's really what I see as the students getting tripped up on where to put the negatives and everything. And that's what messes them up after they understand the basic concept. So if you're still getting tripped up on this, feel free to leave me a comment in the comment section for this video, or you can email me, or you can just do some practice problems that you find online with negative and positives. Make yourself a number line and really get the hang of that. Now this next page is a lot more challenging because now we have numbers in front of the x's, the x squares. So now this adds another level to it. So I'm not saying this to scare you. I'm just saying this to prepare you that it's okay if you look at this and go, oh, yikes, but it's okay. We're just going to dive right in. You know what we're supposed to do. We've gone over what we're supposed to do. It's just a matter of doing it. So this first problem, 36x squared plus 282x plus 46. So what we want to do is we need to factor out both of these, the first and the last sets of numbers. And so we take one number from the 36 multiples and the one number from the 46 multiples, and they go together in one set of parentheses, and then the other number from the multiples of 36, and the other number from the multiple of 46 goes together in the second set of parentheses. And it's just a matter of rearranging them until you get the math to work out right. So when you add the outers and the inners together, that should give you the 282 here in the middle. So it sounds like a lot, but it's just a matter of getting used to it. So if we need to find multiples of 36 and 46. So multiples of 36, we can do a 2 into 36, which is 18, or we can do a 3 into 36, which is 12. For 46, and there's more multiples you could do, but I'm stopping here just in the interest of time because I have the answers already out in front of me because I'm the one that made up the problems. So for 46, we can also do a 2 and 23 go into 46. And then I don't think we have another thing that goes into 46 until way up in the number chain. So we're going to stick with this for right now. So if we take one number from the 36 multiples, and we take another number from the 46 multiple, and put them in one set of parentheses, so that would be 3x plus 2. And then for the second set of parentheses, we take the other multiple from 36. We take the other multiple from 36, which is 12, so we're going to go 12x. And then the other multiple from 46, which is 23. But now we have to go back and we have to put these two parentheses back together again to make sure that it gives us this 282. So if you multiply the outers, the outside numbers, and then you add them to multiplying the inside numbers, that should give us the 282. So multiply the outsides. That's 3 times 23. So 3 times 23 is 69. And then 2 times 12 is 24. If you add those together, 9 plus 4 is 13. That's just 93. So that's not going to give us the 282. So we need to rearrange these numbers. We don't have to use new numbers, but we need to rearrange these numbers so that when the outers and the inners are added together, they give us this 282. So we're going to pick one of these numbers that we factored out, the 36 to 46. So I'm going to pick 46. And these multiples that we're using of 46, I'm going to swap them for each other, swap them out for each other. So instead of what we originally started with, I'm going to put 3x plus 23 times 12x plus 2. So see, I just swapped the 23 and the 2, which were the multiples of 46. So let's try this. So if we have 3, we multiply the outers by the inners, and we add them together, and that should give us 282. So the outers is 3 times 2, which is 6, and the inners are 23 times 12, which is 276. And if you add 6 plus 276, you do indeed get 282. So awesome, that's our answer. And all we did, we didn't put them in right the first time, but all we did was I picked this number 46 that we had multiples out of, and so I swapped the 2 and the 23 in their positions. So I swapped this 2 and the 23's positions, and then that worked out. That gave us the 282. Now the 36 squared minus 270x minus 46. We're still going to be doing factoring the 36 and the 46, and we had used this problem over here. I erased all the stuff because so it wouldn't take up space, but we had 3 and 12 for that 36, and we had 23 and 2 for that 46. But look at this. This 46 is negative, and this is negative 270. So this is going to be a little bit different. But we still might be able to use the exact same numbers. It just always depends. The first thing you check is where are you placing your negative signs, because you might be able to swap those out or swap them, and then it works out perfectly. So if we go 3x, and since this is a positive 36x, this 3 and this 12 are going to be positive, or they could be both negative, but the negative 46 is what we're looking at here. This negative 46 means that one of these multiples, the 23 over 2, is going to need to be a negative, because when you multiply those together, you need a negative 46. And when we are adding the outers and the inners together, we need to be able to get a negative 270. So I'm going to guess that the negative sign belongs on the larger number, the larger multiple of 46, since we're going to need this big, large negative 270 here in the middle. So we can go 3x minus 23 times 12x plus 2. So let's see if this works. If we do the outers, 3x plus 2, that's 6. And the inners, the 23 and 12, is 276. But this is a negative 23 times a positive 12. So that gives us a negative 276. So if we have this 6, and we add negative 276 to it, that's going to give us a negative 270. And that's exactly what we're looking for. So our answer is right. Yay! Now we have a 77 we're going to have to factor, and a 65 we're going to have to factor. These are all positive numbers, so chances are all of our numbers that we're going to use are going to be positive. And our factors, our outers, and our inners added up need to be 146. So let's factor this 77. Well, there are not a lot of numbers that go into 77. One set is 7 and 11, and 65, well, 5 goes into 65, doesn't it? Because every number that ends in 5 or 0 can be divisible by 5. So we're going to go 5, and that's 13 is the other multiple of that. So let's try to plop these into the parentheses and see if they work. All right, so if we have 7, we got to do the outers, multiply the outers together. So 7 times 13 is 91, and the inners is 5 times 11 is 55, and 91 plus 55 is, ding ding ding, 146. Now let's do this one on the right hand side here. This is a negative 36, but it's still got a 65 at the end, but this 65 is negative. So we know that we're probably going to be dealing with the same numbers that we were dealing with over here for the answer, but it's all about the negative placement, where we're going to place the subtraction sign. So let's just try something here. Let's go negative 7, or 7x, and since we're going to do a negative 36x, which is smaller than the 65, I'm going to try to put a negative sign on the smaller number first, and we'll see what happens. I don't know if that's going to be right. I'm just guessing. But, you know, after you do it for a while, you kind of get used to the patterns. So let's see if this works out. I don't know if it will or not. But if it doesn't, we'll just swap the negative sign and the positive sign out for each other, and that should work. So the outers is 7x times 13. So that's 91. We already knew that. And then the 5 times 11 is 55. We already knew that. But this negative on the 5 means this is going to be a negative 5, or negative 55. Well, 91 minus 55 is 36, but it's a positive 36, not a negative 36. So I screwed up, and I put the negative on the wrong number. So I'm going to change this negative 5 into a positive 5, and I'm going to change this positive 13 into a negative 13. So let's see if that works. Now the outers are 7 and 13, but it's a negative 13 now, so this is going to be a negative 91. And positive 5 and a positive 11, so that's going to be a positive 55, which gives us a negative 36 when added together, which is exactly what we wanted.